Okay, so I just realized that we didn't get to the literal equations in 10.7. So I'm going to do one more example from 10.7, and then I'll move on to 10.8. So we want to solve this equation. Now notice there's a bunch of letters here, A, B, C, H, but we want to solve this equation for the variable b, right? We want to solve this for b, which is right here. Okay. So in order to do that, well, let's think about this as a fraction. We have a over 1 equals the square root of b plus h divided by 2c. So I just rewrote it. You can always divide by 1, right? That's not going to affect the result. So as a fraction, you might remember, well, as long as I have a fraction on both sides, I can cross multiply. And so that's the idea here, right? So 1 times the square root of b plus h, right? You could put a 1 there if you want, not necessary though, is equal to a times 2c, or 2 times a times c, right? Okay. Now we just have a regular equation with the square roots. So how do you get rid of square roots? As always, square both sides, so that on the left side, you're left with the b plus h, right? Because the square got rid of the square root here. And on the right side, what do? Notice we're not adding. It's not 2 plus a plus c, right? We're multiplying. So you can write, you're just doing 2ac times 2ac, right? So 2 times 2 is 4, a times a is a squared, and c times c is c squared. So you're just squaring each of these, right? 2 squared times a squared times c squared. Okay, so you're distributing the 2 over each factor. But that wouldn't work if you're adding, right? Then you'd have to FOIL. All right, and it turns out we're almost done. How do you solve for b? Well, we have b plus h equals this mess. We just have to get rid of the h. So subtract h from both sides, right? The opposite of adding h is subtracting h. So on the left you have b plus 0 equals 4a squared c squared minus h. That's a 4. And we're done. We've isolated the b. That's the solution. Okay. So yes, there are problems where you might have square roots, but you also might have fractions or literal equations or things that you've dealt with earlier. So I hope that helps, and maybe just for good measure, we'll do one more. So yeah, we'll do one more example. Okay, so the equation is g equals d over the square root of mr. Okay, and we're solving for the letter r, the variable r here, right? This r here. Okay, well, again, we have a fraction on the left, g over 1, and a fraction on the right, d over the square root of mr. Okay, so cross multiply. Multiply g times the square root of mr. Be careful not to put the g under the square root, right? And equals 1 times d is d. Right, so that's the other cross multiply. Right, remember we're solving for m here. I'm sorry, we're solving for r, not m. We're solving for r. So this is supposed to be an r. Forgive the sloppiness here. And so we want to get rid of everything else. So why don't we just divide by g? Divide both sides by g here. And on the left, we still have, right, the g cancels. We still have a square root of m times r. And on the right, we have d divided by g. All right. So by doing all this, we've isolated the square roots. The square root is on the left, no square roots on the right. So to get rid of this square root, yep, square both sides. All right. And by squaring both sides, by squaring the left side, you get rid of the square root, so you still have m times r. And on the right, this is d times d, d squared, divided by g times g, g squared. So you get d squared divided by g squared. Only one thing left to do, get rid of the m. Right? But be careful, this is not m plus r, this is m times r. So we're not subtracting the m, right? The opposite of multiplying by m is dividing by m. So divide both sides by m. And you cancel the m's on the left. And on the right, sorry, that's still an r. On the right, you get d squared times 1 over g squared times m. And that's it. That's the r, right? So r, here's the original equation. We solve for r. R equals d squared divided by, g squared m. Okay, I mean, obviously you could check by plugging it in here, but that's, it's probably not worth it in this case. For literal equations, it's usually a little bit more difficult to check. So I think we'll leave it at this, right? This should help you with most of the problems involving literal equations.